two pieces of news dropped in the semiconductor world that, when you put them side by side, kind of paint the picture of where AI is actually heading. The first one is NVIDIA announcing the Vera Rubin, their next AI computing platform, and by some margin, the most powerful thing that they've ever built. The second is ASML. This Dutch company almost nobody outside the industry talks about, saying their next generation chip printing machines are finally ready for mass production. Two different companies, two different announcements, but they're basically two halves of the same story. Let me walk you through both. So, Blackwell, NVIDIA's last platform, was already a monster. We're talking about a system that could run trillion parameter AI models at 25 times less cost and energy than what came before it. People lost their minds over it, and understandably so. I was impressed. Then Jensen Huang showed up to the CES in January and basically said, yeah, that was a warm-up. The Vera Rubin isn't just a new GPU, it's a full 6-chip system. The Vera CPU, the Rubin GPU, NVLink 6, ConnectX 9, Bluefield 4, and Spectrum 6, all co-designed to work as one unit. The flagship configuration, the NVL72, puts 72 Rubin GPUs and 36 Vera CPUs into a single rack. Stack a bunch of those together and you get NVIDIA's DGX SuperPod, which is essentially a private supercomputer that companies like Google, Microsoft, and Meta are going to spend billions of dollars acquiring. Now here's where it gets real. Compared to Blackwell, Vera Rubin delivers 10 times reduction in inference token cost, training the kind of large mixture of expert models that power today's frontier AI requires 4 times fewer GPUs, and the efficiency jump is 10 times more performance per watt than Grace Blackwell. It's kind of a thing that makes data center operators genuinely excited, not just because it's impressive on paper, but because energy bills are becoming one of the biggest costs in running AI at scale. There's also the Rubin CPX variant, built specifically for massive context processing, million token coding tasks, generative video, that kind of thing. The NVL144 CPX rack packs 8 exaflops of AI compute with 100 terabytes of fast memory and 1.7 petabytes per second of bandwidth. That's 7.5 times more AI performance than the GB300 system that are still being backordered right now. And NVIDIA's internal numbers put the token revenue potential at $5 billion for every $100 million invested. Cloud companies don't need to hear that twice. Now, what I find most telling isn't the specs, it's the commitment list. AWS, Google Cloud, Microsoft, Oracle, and CoreWave are all deploying Rubin-based systems in the second half of 2026. The AI labs lined up include OpenAI, Anthropic, Meta, Mistral, xAI, and Perplexity. Microsoft is building what they're calling Fairwater AI superfactories around the NVL72 rack systems. Meta has confirmed Vera Rubin deployments in their own data centers by 2027. These aren't pilot projects. These are infrastructure bets. Dell, HPE, Lenovo, Cisco, Supermicro, they're all building servers around it. Rubin is already in production. Jensen said so himself. Now, I'll be straight with you. I think this is one of the most well-engineered pieces of computing hardware ever built. The decision to co-design 6 chips as a single system rather than just scaling up a GPU is a fundamentally different approach, and I think it's the right one for where AI workloads are going. The price is real, though. Around $3.5 to $4 million per rack, according to Futurum Group. But when you're generating billions in token revenue, the economics work out fast. And yes, AMD and the hyperscalers in-house chips are getting better. But NVIDIA's moat isn't just the hardware. It's 6 million CUDA developers and nearly 6,000 applications built on top of their ecosystem. That doesn't disappear overnight. Rubin buys them another full cycle of dominance, minimum. Now, it's time for me to tell you about ASML, the machines that print chips. Specifically, they make EUVs, extreme ultraviolet lithography machines. They are the only company in the world that makes these. If ASML can't sell you a machine, you can't make cutting-edge chips. Last week at a technical conference in San Jose, ASML's CTO Marco Peters told Reuters that their next-generation machines, the High-NA EUV tools, are ready for high-volume production. The industry has been waiting years for this announcement. The current EUV machines that print NVIDIA Blackwell chips are essentially maxing out. They're a physical ceiling to how small and dense you can make a circuit patterns with existing tools. And the AI chip industry is running straight into that ceiling. More transitions, smaller nodes, tighter tolerances, it all demands better printing precision than current machines can reliably deliver. High-NA EUV, the NA is a numerical aperture, basically a measure of the lens system resolution, breaks through that ceiling. The higher aperture lets manufacturers print finer circuit patterns in a single pass, replacing what used to be multiple sequential steps. Fewer steps means fewer chances for defects, faster throughput, and ultimately chips that are smaller, faster, and more reliable. Now, Peters didn't just make promises, he showed up with data, and I think it's worth noting because this industry runs on vaporwave announcements more often than anyone admits. The High-NA tools have now processed 500,000 silicon wafers. For context, these are the diner plate-sized discs that get sliced into individual chips, each one yielding dozens or hundreds of chips depending on the design. The machines are running and productive 80% of the time, with a target of 90% by end of 2026. These machines aren't cheap. They cost $400 million each. TSMC has systems for testing, though they're being strategic. Their VP Kevin Zhang had suggested the A16 node can proceed without High-NA, and analysts expect full deployment around the A14 node, probably in 2028. Intel is moving a little bit faster. They're already the furthest along in integrating High-NA into their 14A process, essentially betting that getting ahead of this technology helped them compete with TSMC again. Now, I find it genuinely strange how little coverage ASML gets outside industry circles. Every conversation about NVIDIA's dominance, every debate about which AI lab has the best chips, all of it runs through ASML. No ASML machines, no TSMC production, no NVIDIA chips. The whole stack depends on them. This announcement is, in my view, one of the most important semiconductor stories of the past 2 years. It sets the trajectory for every AI chip node after 2027, and that's not a small thing. Now here's how I see it. Rubin is NVIDIA's locking in the present. High-NA EUV is the industry's unlocking the future. One story is about what the most powerful AI systems will run on through 2026 and 2027. The other is about what makes the chips that come after that even possible. They are not independent developments, they're connected, and the fact that both happened within the same week tells you something about the pace of where this is all going. I'll be watching how fast TSMC moves on High-NA adoption, and how Rubin rollout looks by Q4. And honestly, what Jensen announces next, because at the rate NVIDIA is moving, another platform reveal is probably closer than any of us expect.